Why is Mars a dead planet, yet Elon Musk still wants to colonize it? In 1964, the American probe Mariner 4 became the first spacecraft to fly past Mars and send back images. Scientists concluded that humans cannot live on Mars. The reason is simple. Mars has lost its magnetic field. Its atmosphere is extremely thin and completely unable to block deadly solar radiation. Transforming Mars into Earth is entirely impossible. However, Musk believes that Mars is the only planet in the solar system suitable for human settlement and capable of being transformed. Therefore, he has repeatedly declared that he intends to build a city on Mars for 1 million people. In fact, the real challenge is not whether we can get there, but how to survive and return. Today, we will not talk about romantic visions, only about realistic calculations, how many people are needed, how housing will be arranged, and how food will be supplied. And there is one final harsh question. Is colonizing Mars ultimately worth it? The first challenge of the mission is not technology, but people. This is not space travel, but an extreme survival mission lasting nearly 800 days. It takes 6 to 8 months to reach Mars, 500 days living on Mars, and another 6 to 8 months to return. Nearly 3 full years of isolation from the world, seeing Earth from Mars is only a faint blue dot. Even more desperate is that communication between Earth and Mars is delayed by 5 to 24 minutes. This means direct phone calls are impossible. And in the event of an accident, rescue cannot arrive immediately. When you send a message to Earth, you may have to wait more than half an hour for a reply. This level of isolation cannot be simulated by any experiment on Earth. In June 2011, 6 volunteers lived in a sealed habitat for 520 days. Those conducting simulation experiments know that if anything goes wrong, they can press the stop button at any time. But a real journey to Mars offers no retreat. Once you launch, you become the loneliest person in the universe. Therefore, the psychological condition of astronauts is the top priority. We need people who are extremely calm and resilient, who can endure more than half a year in confined spaces and skillfully resolve conflicts that arise within the team. Even among the best volunteers in simulation experiments, 4 develop psychological or sleep disorders, and this is only on Earth. Once the journey to Mars begins, the greatest challenge is cosmic radiation. From supernova explosions outside the solar system, high-energy particles are emitted that can easily penetrate spacecraft hulls. Calculations show that just the round trip to Mars will expose astronauts to radiation approaching the career safety limit. Selection standards therefore become harsh and counterintuitive, prioritizing men over 50 years old. The second reason is that, statistically, the risk of lifespan reduction is relatively lower for older individuals. Suppose 4 people are selected. The next question is where they will live after landing on Mars. The spacecraft that carries them there is not suitable for long-term habitation. A dedicated settlement on Mars is required. Transporting supplies from Earth to Mars is absurdly expensive. Every kilogram of equipment set requires 225 kilograms of fuel. The only solution is to use local materials. Martian red soil must be used to build houses. At present, scientists have proposed 3 approaches. The first approach is 3D printing Martian fortresses. NASA once held a Mars habitat design competition. One of the best designs was a vertical cylindrical structure with double walls. The middle layer is filled with insulating material. Robots would land first to mine and refine sand, similar to grinding toothpaste, and print the habitat layer by layer. When astronauts arrive, the houses would already be completed. The second approach is inflatable modules. NASA is currently studying ice-based architecture. First, an inflatable framework is erected, and then robots fill it with Martian ice. Water ice not only retains heat, but also blocks deadly radiation. Its semi-transparent properties also allow sunlight to pass through. It is essentially a natural villa. The third approach is to live directly underground on Mars, making use of lava tube caves beneath the Martian surface. This is the safest option, providing natural protection against radiation, extreme temperature differences, and meteorite impacts. But the question remains, where will energy, air, water, and food come from? Even after the houses are built, they are only shelters. The life support system inside is the true core. Using solar energy is not the optimal choice. Sunlight on Mars is weak, and there are terrifying global dust storms that can last for months. The Opportunity rover completely lost contact due to a dust storm. For astronauts, loss of power means catastrophic extinction. Unless solar power is built in orbit near Mars, energy remains a major risk. After energy, oxygen, water, and food are also required. The Martian atmosphere is 95% carbon dioxide, and oxygen accounts for only 0.15%. Oxygen can only be extracted from carbon dioxide. In April 2021, the MOXIE device carried by the Perseverance rover successfully produced oxygen. However, the oxygen production system would need to be expanded 200 times to meet the breathing needs of 4 people for 1 year. There is a large amount of water ice beneath the Martian surface. Robots can be sent down to dig, melt, and purify it to obtain drinking water. More importantly, a powerful water recycling system must be installed to recover and purify both urine and sweat. Water can also be used as raw material to produce return fuel. The biggest problem is food. Martian soil is toxic and cannot be used to grow vegetables. The solution is aeroponic cultivation, allowing plant roots to hang suspended in the air. Experiments by the European Space Agency in Antarctica successfully harvested hundreds of kilograms of vegetables. The entire life support system weighs about 24 tons. The most troubling issue is what to do if astronauts become ill or homesick. In Earth orbit, illness allows for an emergency return. On Mars, they can only rely on themselves. Because of the communication delay, astronauts on Mars who encounter emergencies must make decisions independently. They cannot wait for instructions from Earth. They must solve all problems on their own. Therefore, many scientists believe that sending a small number of astronauts to Mars is relatively feasible. But building a city of 1 million people in a short period of time is almost impossible. Humans live well on Earth, yet travel to distant Mars simply to survive. Is it truly worth it? At present, rapidly advancing artificial intelligence is expected to become the main force in future Mars exploration. Perhaps we should consider an army of humanoid robots. They do not need spacesuits, are not afraid of radiation, do not need to return to Earth, and can work around the clock. Currently, 3 companies have outlined a closed-loop system. SpaceX builds and manufactures space transportation vehicles to reduce costs. Tesla develops intelligent robots trained to handle harsh environments. Neuralink develops brain-computer interfaces that connect humans and machines. Thus, a bold hypothesis has emerged for future space exploration. Humans may not need to go themselves. Our consciousness, through brain-computer interfaces, could remotely control robots on Mars. Our bodies would remain at safe bases on Earth while our minds roam across the red plains. Is this the inevitable outcome of technological development or a deliberate design by capital interests? No one knows the answer. But one thing is certain. Whether humans set foot on Mars or intelligent robots do, this exploration will be the most extreme conquest of human intelligence.